So, I think I've got 5:31. Looks like some people are coming in, but we will go ahead and get started. So, welcome everyone to the Bluegrass Area IMA Chapter meeting for September 2020. I will request, I think most everyone has, but if you would, go ahead and mute your microphones so that we don't end up speaking over each other. So by way of agenda, so I'll do brief introductions, then just what is data visualization, then good and bad, and some closing thoughts, and time permitting. Maybe we'll get into even some tips, tricks, some tools in Excel that perhaps you may or may not be familiar with. So first, who am I? My name's Dr. J.P. Stearns, CMA, CPA, and I've got a bunch of other letters that my wife makes fun of me for. I'm an assistant professor of accounting here at Eastern Kentucky University. And apparently, for those of you that are not in Eastern Kentucky, we're just a little bit south of Richmond. We've got some people that joined from around the country, and that's exciting for us. I am also president of the Bluegrass Area IMA Chapter, and there's my contact information if you want to shoot me an email. If you have questions, want some more resources, feel free to reach out to me. As the IMA Chapter President, I want to thank everyone for attending. Looks like so far we've got a pretty strong turnout we're excited about. Now, if this is your first meeting or first in a while, I do want to welcome you. And normally when we're not in the middle of a pandemic, we meet or have been for the last year or so at the BCTC Newtown campus in Lexington. In-person meetings, we tend to have some food, so there's a small cost for that, but usually a time of networking and a presentation like this. And hopefully in the near future we'll be able to welcome everybody back and get together in person. And certainly feel free to join us for those. And if you'd like more information about the chapter or want to get involved or make sure that you're on the distribution list, because sometimes with the IMA, getting communication through their system, sometimes we don't always get our email updates. Make sure to reach out to myself or one of the other board members. And also, if you have ideas for speakers or people that you think would be exciting speakers or just topics that you'd like us to try to recruit in, again, reach out to us. Feel free to shoot me an email. We want to hear from you. Now, as a assistant professor here in the School of Business at EKU, my dean would give me a really nice sort of NCIS head slap if I didn't mention our initiatives to have a positive impact in the Bluegrass area. We are AACSB accredited here, so that's part of our mission, to help enhance and grow the economy and have help professionals in the region enhance and grow their skill set. So we want to connect our expertise with our community members. So if you think that that might be something of interest to you, feel free to reach out to me. Now, before we go further, some of the sort of legalese, if you will. If you've seen some of my presentations, more technical, and for the IMA, I'm a huge baseball fan, so some of the examples I'll be showing you is some baseball data pulled from SeanLehman.com, where he keeps a baseball statistical database. It's licensed under Creative Commons, so we are free to use that as long as we cite him, and that's what we're doing here. Now also, many of the principles that we're going to be talking about in this presentation come from the work of Edward Tufte, particularly his visual display of quantitative information. If you're not familiar with him, I encourage you to check out his website, which is listed there, and his other books as well. He's probably the leading mind on data visualization, and his works have become the seminal works in this area. I will probably cement my reputation as a quant nerd when I tell my wife that for Christmas I want the cloth-bound autographed 4-volume set that you can get on his website. So, but great work, and if this presentation piques your interest, I encourage you to look into his work. So, first question is, what is data visualization? Now, it's a major topic in business. We hear a lot about it, but a lot of times it gets commingled with other topics like dashboarding or some of the business intelligence software, and we kind of bypass what is actually a good visualization. What are the principles that make a visualization effective or not effective? So that's where I wanted to focus this presentation today. So let's start with how Mr. Tufte describes it. So for him, data visualization is visually displaying measured quantities by means of the combined use of points, lines, a coordinate system, numbers, symbols, words, shading, and color. And so kind of pulling that apart, what I see are kind of 3 different components. So there is clearly data. So we have some kind of quantitative data that we are trying to present, and we have insights that we need to pull from that data. And then we're going to communicate those through some artistic means, through lines or colors or shading, symbols. So for me, data visualization is the intersection of those 3, where we're identifying insights to be communicated, but then using artistic means to do so. And I think that leads us to the kind of the core principle that we'll come back to several times in this presentation, is that we are visually representing insights tied to our data. And that is really at the core. Is it how effective and efficiently are we communicating those insights? Now, those may be simple insights like quantities or just some 2 variable relationships or trends. They may be more complex, geographic or multivariate relationship. But regardless, there are some core principles that can guide the creation of effective data visualizations. So, with that, let's move on to what makes good data visualization. So now, ultimately, excellent data visualizations are built on 3 kind of core principles. The first is substance. We're communicating data, and that data has to have some significance. And at the end of the day, our data visualization is only going to be as good as the data we're communicating. If we have fluff for data, our data visualization is not going to be amount to much. Likewise, the data visualization needs to convey accurate insights into that data. So that's what we're trying to communicate, is insights we draw from the data, and so that's going to be built on the analysis, the statistics we choose that we apply to that data to make those insights. And then we need to communicate those values, those insights with integrity. Critical that whatever we're putting on our charts, on our graphs, on our tables, has to accurately represent the analysis performed. And then where we're going to spend most of our time today is on the design. So the choices we make about how we present those insights. And there are many choices that and those decisions we make can either more efficiently and more effectively communicate our insights, or they can actually misconstrue and confuse. Now, with that, from that is probably our first concept, and that is good designs tend to favor simplicity over complexity. That is, like many things, really effective visualization conveys a possibly very complicated concept or insight with simplicity. It makes it actually easier for our end user to digest the information. Now, kind of with that, one point I want to make is sometimes a graphic is not the best choice. Many times, especially for simpler information, though that information is more effectively communicated in a table. And that may not be as visually exciting, but again, if that is what more effectively and efficiently communicates the ideas, that may be our best choice. And by way of example, I want to start with my baseball analogies here. The 2011 National League Central batting statistics. Now, if you're a sports fan, you've probably seen tables like this, so much so that we kind of lose sight of exactly how much information they're giving us here. So while this is a fairly compact, straightforward table, what we've actually got here are 5 data series effectively presenting their totals. We could, without adding too much clutter, maybe drop in some percentage columns, so what percentage of the total hits each team had. That wouldn't add too much clutter. And we've got our categories by the teams. So this is, in actuality, quite a bit of information conveyed quite effectively in a very succinct manner. Now, to kind of point out exactly how succinct and how much information, let's look at a visualization of just a portion of this table. So if we look at this visualization, we're getting just the hits column by table, and so first we see that we've lost a lot of information. But then as we look at this, and this is intentionally a poorer visualization, we see that there's some things that are confusing. One, it's harder to read. We've got to jump down to the column, figure out the colors, and as an end user we're having to jump back and forth. And then we see something odd, that some of the wedges look a little off. Like the Cubs here in blue had one more hit than the Milwaukee Brewers, but that 1422 wedge sure looks a lot bigger than that 1423. And when we get to the bad visualizations, we can we'll actually see some of what's driving that. So how can we improve that visualization? What would make that better? Well, we could simplify it with a bar chart, a column chart. Not maybe as visually engaging, it's not as exciting, but it does many things better. Now we could spice this up. Excel has many tools to do that. We could add some lines or some gradients, but as a general rule, unless we're intentionally adding something that tells us more about the data, we should probably avoid too much busyness, accessorizing the chart too much. Now, what exactly does this bar chart do better? Why is this a better presentation? Yes. So first off, as we were mentioning that a couple of those wedges looked a little off, we've only got one dimension of change here. So our dimension that is changing is the height of the columns. So that is a first principle, that each change in the visualization should correspond to a change in the data. If we start having other dimensions that don't actually reflect the data, we confuse the visualization and can lead to misinterpretation by our end users. Likewise, and kind of built from that, the changes are proportional. So the height of the bars change with the quantities of the hits by the teams. So that's a proportional change. And more often than you imagine, even preparing visualizations in software packages, we see, because we wander into the more complex graphics, changes that are not reflecting the proportional change to the data. So that's kind of our first two principles of good data visualization, is that we need to be conscientious of that changes in our data representations are proportional to changes in the underlying data, and that the dimensions we're showing on our graphics are the same in number to the dimensions of the data that we're representing. Now also, what we see here is well, I could have done more with the chart label, but the data is actually pretty cleanly and well labeled, and more intuitively than the previous pie chart. So our teams are across the bottom, clearly aligned with their columns. We've included data labels for the totals, and we can effectively compare them. So labeling appropriately, not so much that we clutter up the chart, but cleanly giving our end users the context they need to better digest the information is an important principle. Even to the point of, if appropriate, including a small blurb or a text box on a chart, if those words provide additional context that help the end user better understand the data. So don't be afraid of adding words, using words. Not so much that they clutter up the chart and make it more difficult to read, but if they provide context, do absolutely include explanations and cleanly, copiously label important data points on your representation. Now, this is a simple data set, very, very simple. What might we do if we have much more information to communicate? Many times we've got a large number of variables to communicate data about. Now, there is a principle that Tufte talks about called small multiples, and I can make just about an entire presentation on this, but I'll try to just kind of whet your appetite and not go on too long about this. So this is a report you may have seen if you're familiar with Consumer Reports. They rate everything from obviously bank cards to automobiles to washers and dryers. And maybe you don't even consider this a visualization, but it is. And in fact, it's a very clever combination of a chart and a visualization. So in the visualization, we've got colored circles that give us different categories of ratings for the series of different ways they're evaluating these bank cards. Now, what they've done cleverly here is use the small multiple. So a small visualization repeated multiple times to convey, in actuality, a substantial amount of information about each card and about the card set as a whole. Now, unfortunately, I couldn't find an image that was licensed appropriately to be used in this presentation. Probably their most well-known implementation of this is with automobiles. And they use the same kind of colored dots across repeated charts for many, many different automobile makes and models, across dozens of auto repair categories, and within each table they've got several years. So they're using that small multiple principle to convey substantial quantities of information about a wide range of models to give the end user a better grasp of how reliable each model is. Now, what's that principle telling us is that we can use a simpler visualization about just a couple of variables that's easy to digest and repeated multiple times to convey much more information much more clearly than we would in a more complex visualization trying to put all those variables into one chart or graphic. For example, in a business context, we might look at some kind of performance valuation metrics or financial ratios over several quarters. So instead of trying to make a complex graphic showing several ratios over 8 or 12 quarters, we might better convey that information in a more digestible format to our end users with several smaller charts that are much easier to read themselves. And again, you can read more about that if that might be of interest to you. Now, the takeaway at this point, some of you might be feeling, well, okay, so the takeaway is to essentially avoid fancy graphics and just stick to bar charts and line charts. And now, while simplicity is a virtue, and usually we should err on the side of simplicity, that does not mean that visualizations cannot be rich and visually engaging. Now, as an example, here's a kind of a heat map of lung cancer mortality across the United States. Obviously, much more engaging than our bar chart. It's showing all the. Can we please make sure to mute your microphones? Or Sandy, I think you can mute everybody.
Okay.
All right.
Got it.
Thank you. So, regain my train of thought here. So, this visualization does most everything well, many things well, and I wanted to highlight what it does well and the challenges in these kind of visualizations. Obviously, heat map is an exciting, visually engaging graphic, but when we're presenting them, there's a couple of principles that we need to really make sure we're grasping. And the first off is that the underlying basic dimension here is geography, so it's space. And the presentation equates space equally as this. So a square mile in southern Florida down here is the same as a square mile here in eastern Kentucky. And that's true. The challenge of it, and we're getting data like this, is that the quantities are not driven explicitly by space. A square mile doesn't change lung cancer mortality. So obviously behavior and population density will have much more impact than straight geography. So, and what this chart does well is it makes sure to account for that in using a standardized basis. In this case, rates per 100,000 population. So, and that's an important principle to realize is when we have a dimension like population that is relevant but not explicitly in our visualization, we need to make account for that, in this case by standardizing on a per capita basis. Now, the other dimension to account for is that, again, we're implicitly implying here a correlation between geography and these rates. And there does seem to be a correlation here. Certainly southeast, where tobacco was a major crop for a long time, seems to have greater, and we've got some other cases. But there could be cases of just spurious correlations, or chance is lumpy, as they say, and we need to be prepared to provide context for that. If there's something unusual like this county over here, we may again need to be prepared to provide context for that if we're going to present this data visualization. Be prepared for spurious correlations and be able to explain those and defend the correlations we are implying here. Now, no presentation on data visualization would be complete, especially one that's referencing Edward Tufte's work, without probably the most famous visualization he's presented in his works, which is which is a chart graph prepared by Charles Joseph Menard in 1869, depicting the progression and the size of Napoleon's Grand Army on its Russian campaign, predominantly in 1812, I think, as the chart indicates here. It did perhaps extend a little bit into 1813, but predominantly it was the summer through the winter of 1812. Now, Tufte cites that this may in fact be the best data visualization ever prepared, and there's several principles we can take away from it, and it's implementing those that we've already talked about extremely well. And then we'll walk through some of those. The first is it makes excellent use of, again, words to add context. And I would cite that by including the year dates here, and that this campaign is pretty much encapsulated in a year, it saves us cluttering up the graphic itself with date lines. We don't need those. We've already explained that. So we can declutter the presentation. Now, it also, as we mentioned, makes excellent use of effective data labels to highlight key geographic points and towns and cities along the advance and the retreat of the Army. So it's made copious labeling, made sure not to clutter up the graphic, but it adds context and for the end user that's important. It uses a proportional scale to show the advance and the distance. And then the most fascinating feature, and probably the stroke of genius that Menard had here, was to use width to demonstrate the change in the size of the force. So when they first crossed this is the Niemen River here, they had approximately 500,000 in their force, and then as they progressed through, both with engagements with the Russian forces, some desertion, some captured, and succumbing. I'm trying not to make this a history lesson, but the Russians were using a strategy of strategic withdrawals and kind of scorched earth to make sure that the force could not use Russian crops and Russian resources to sustain itself. So 500,000 force is a lot of people to try to sustain. So they lost people because they didn't have food and water. And so this band gets smaller, showing the reduction of the force sizes until they reached Moscow and then began the retreat. And again, here is a very effective use of color. Again, we can add color, feel free to use color, but use it effectively, and so it demarks the advance from the retreat. And then we see, again, geography as they move back towards their home territory. Now, probably the most impressive feature is actually the bottom here, where again we add another dimension to the graphic, and that is the temperature as the retreat began in the Russian winter, and we compare that with the size of the force dropping as the blisteringly cold winter set in, getting into well below zero temperatures. So that is we've got several dimensions in one graphic, quite effectively presented. And that leads us probably to the greatest takeaway here, is that kind of a two-part, that graphics and visualizations can be visually engaging. They can be elegant, bordering on art. Many would argue this is actually art quality visualization. But they do that not by adding complexity for complexity's sake, but by layering simple representations. So nothing in this graphic is a overly complex representation in its a line chart, its length, its distance, proportionally represented. But by layering several of those together intentionally and effectively, we create an elegant and extremely effective visual representation. So, what are good visualization principles? Again, to sum this up, first off, our choices matter. Our data is only as good as our representation, our visualization is only as good as the data that it's based on, the analysis, and our faithfulness to that analysis in the representation. A great visualization is focused on communicating the insights that it's making clearly and effectively. Our design choices are secondary to being faithful to that representation and clearly communicating that. Each change in the visualization should have a corresponding change in the data. So if we add a dimension to the representation, then there should be an underlying dimension in the data that we're presenting. All of our changes in the visualization should be proportional to the underlying data. Small multiples can add value, and while simplicity is important and that's a virtue, great visualizations do not need to be boring. They can even border on art and be extremely visually engaging. And speaking of being visually engaging or interesting, what are bad visualizations that can be interesting but not effective at what they're purporting to do? So we'll start with a topic we've already touched on, and that is our dimensions. And the issue with some of the fancier graphics that things like Excel and Tableau present is that to be striking, they often add 3D elements that change dimensions that don't have a tie to the data. Now, another dimension that we sort of mentioned in the heat map instance is when we have underlying dimensions that are relevant but not explicit. When we have situations like that, we need to standardize. As we said, standardizing for population changes between the counties, using a per capita basis. Financially, when we're presenting a time series, many times the value of the underlying currency has changed due to inflation, and that can dramatically change the purchasing power of the values we're representing. So if we're talking about a basic financial statement series, just a couple of years, probably not significant, but if we're showing performance over a longer time, maybe 10 or 20 years, then inflation and the value of the currency will be extremely relevant and should probably be standardized on some kind of base year. So express everything in 1990 dollars, for example. Now let's come back to the 3D graphics and the pie chart we showed earlier. So what are the issues with this? So as we can sort of express before, certainly it's more difficult because our end users are having to move apart, but what makes this problematic is this additional dimension. So this is a pie chart, so we're divvying up the face of the chart, but then because we've chosen this 3D representation, we've added a depth dimension that's not explicitly part of the representation, but to the end user it makes these forward, more upfront wedges look larger. So we've created an optical illusion that a representation that distorts the value. So that makes, again, even though these two wedges are only one hit apart, this yellow Milwaukee Brewer wedge looks much larger than the Cubs' 14-23 hits, which are actually more. Now, I'm all for the Cubs having fewer hits, being a Cardinals fan, but we should be faithful to the data. Now, the other change that, again, makes this representation problematic is we've sort of created an angle. We've tilted the pie. So, again, that creates an optical illusion that makes the further away slices look a little smaller, relatively speaking, than the more forward wedges. And I think that's even more pronounced in this visualization, which Tufte actually speaks a substantial bit about. Again, we've got a graphic that's creating a three-dimensional effect. So the lines representing a fuel economy in this case, further away, are smaller and look even smaller than they may actually be. Although we've got problems with proportional representation here. So what the graphic is trying to tell us is demonstrate the change in fuel economy standards from 1978 up to 1985. And by the art, you can tell this is probably a mid-80s graphic. Now, what has happened here is, in an attempt to be clever and make a visually striking graphic, we've created a huge error. So the fuel economy standards went from 18 miles per gallon to 27.5. So that's roughly 1.5 times. I think it's actually 153%. So it's 27.5, so 153% of the 18 baseline. However, in the graphic, the line representing it is 0.6 inches long, and in the original graphic, this 27.5 is 5.3 inches long. So that's, instead of being 153% change, that's an 883% change. So to represent a fuel economy change that's 1.5 times greater than its base, we're using a line that's almost 9 times greater than its base. So, obviously not proportional and problematic. And we're going to assume and hope that this was just an accident being clever with the graphics instead of trying to be intentionally misleading. Now, the graph, in terms of interpretation, has another problem. And that is that it doesn't have a common base. So, while we can judge differences in height and length pretty well, humans do that pretty intuitively. It's more challenging when there's not a common baseline. So if we go back to the bar chart, everything started from the same base. Here, what we're seeing is that both ends are expanding as we move further up the graphic. And we're trying to judge how much larger that is when both ends have changed. And that kind of moves us into the next, which is our choice of medium. Many times we have a poor match, our graphic is just a poor match, or it's difficult to interpret, like that was, where we're forced to try to understand how much both ends have grown, or it's a complex presentation with just too much going on. Like this graphic, which is created in Excel. It's called a sunburst chart. It's right in the list of graphics. And what we see is that there's just too much going on, which is a problem in this class of graphics that I'm going to call area graphics. That is, they do not handle more than just a handful of categories. And there's some distortion going on here because in 2011 the National League actually had more teams than the American League. But that's not explicit. But the biggest problem is in the outer circle here, and that is that even though those rectangles change for the number of hits, so the area is accurately representing proportionally each team's share of hits, it's difficult to compare. We can see Seattle, which I believe had the fewest hits, is about 80% of Boston, but to try to gauge that in this graphic is very, very difficult, and it's a cluttered. And that's partly because there's too much going on here, but it's also because just by our nature, humans do not as intuitively interpret area nearly as well as they do length or height. And we can look at, again, these are donut graphics, again, straight out of Excel. So we can scale back the number of categories, but it's still, we see that they are difficult to interpret. Trying to see that we at least see these two are closer better, but exact proportions are difficult to digest without including a lot of data labels. And that leads us to kind of a guiding principle that, as a rule, these area graphics are generally suboptimal choices, including the pie chart. They're much more difficult to interpret, it's hard to tell, and they're only good for really, at most, just a handful of categories. And most of the time, you're going to be better served and much more effectively communicate what you're trying to get across with a column chart or something like that. Now, I did save probably the worst for last, and that is what's called a tree map. And this I would classify as chart junk, which we'll talk a little bit more about down the road. Now, what the tree map suffers from all the same problems is that once we get beyond just a few categories, it becomes very difficult to interpret. And now, two things really I have issues with the tree map. The first is not so much the graphic itself, but that if you when you go to, and these are popular sessions at most professional conferences that are demonstrating some kind of data visualization software, maybe Tableau, maybe Power BI, something else. Oftentimes, you will see a visualization like this thrown up as a feature. Now, what's usually going on there is that these are used to highlight the software's drill down feature. So you click on a team or a business unit, and you can drill down to the next level of detail and to the next level, so on. And drill down's a great feature and important in those kind of software packages. Now, as a visualization itself, this type, while it's got a lot of wow factor, is problematic because, along with the issues that the other area graphs have, that they're just more difficult to interpret, it adds in, we're changing the size of the wedge. So we're using rectangles here, and we can note that the Washington, Pittsburgh, San Francisco, and even Tampa Bay all are within 6 or 7 hits of each other. So those areas for those rectangles are really close together. They're very similar, but because we have changed the shape, we're dramatically reducing the comparability such that they don't look, and we're not going to interpret them as approximately the same. Washington's is squeezed and very tall, Pittsburgh's is more square, San Francisco is still a rectangle but a little wider, and then Tampa Bay is tipped over on its side, making them next to uncomparable. And on top of that, without these data labels, which clutter up this graphic quite a bit, it's almost, we're conveying next to no information to give us comparability and totals. Now, just for fun, let's show what a pie chart looks like when you have way too many labels on it. This is 30 slices, and again, without data labels, it becomes conveying next to no information. So, principle here, area charts tend to be problematic and are going to reduce how effective you're communicating your information, so probably stay away from them. Again, sometimes a pie chart might be useful to show composition, but only for a few categories and probably only with some copious labeling likely including the proportions. Now, related to that, I wanted to spend just a moment on a chart that we see quite a bit in business reports, and that is the stacked bar or the stacked area chart. And again, I hesitate to call these bad. They serve a purpose, and that is usually to show the composition of a total, but it's very difficult to say drill down, to really tease out the amounts, because the baseline is changing. So let's say, again, we're using some baseball examples here. So this is our hits, and we can see, the composition of singles, doubles, triples, and home runs, how that tallies out to the total hits. And so we can see, you get a rough gauge of the proportions of each. But if we want to compare, say, home runs across teams, we have a challenge is that the totals, we got to figure out some subtraction, but then our baseline is changing as the bar height moves. So to compare that smaller slice across teams becomes very difficult. Likewise, the same issue happens with this stacked area chart, where, again, if we wanted to focus on the home runs, trying to compare home runs in 2006 to, say, 2017 becomes very difficult, because we don't have a common base to see, okay, how much has that increased. Our baseline is moving, making our interpretation much, much more complicated. So again, as a guiding principle, limited use for these kind of charts, but they add some complexity, and more than just a basic composition guideline, they're going to be very difficult to digest by your end user. So, a word on chart junk. And this is actually a phrase coined by Edward Tufte to highlight particularly egregious data visualizations. Sometimes they're driven by intentional deception. We could be intentionally try to hide, using inconsistent changes, again, violating a core principle of proportionality, the no baseline issue, or probably more commonly, an incorrect baseline. So whereas, and we talked about this graphic before, we have no baseline for comparison here, what we see quite often is playing with the axis to not start at zero, to either expand our axes and make small changes look bigger than they actually are, or increase our axes and compress changes to look not as dramatic as they actually are. And again, that's being intentionally deceptive and violates some of our integrity principles. Now, more unintentional can be that we're trying to be clever with our visualization and not realizing how much change we're creating to represent smaller change. So that's an example here with this dollar bill, that we're trying to show changes in the minimum wage, and what can happen is we're making the dollar bill longer to represent proportionally the change in the minimum wage, but we forget that to keep that dollar bill looking like a dollar bill, we've got to also change the width. So we end up changing the area much more than we intended. So it's a much larger magnitude change than was actually occurring. Probably unintentional, but that leads to chart junk. Now, it could also be that we're trying to show a fancy graphic and didn't think about being proportional, and we just made it bigger, and then the visualization, which is what our end users are focusing on, completely distorts the underlying data. So again, that comes back to focus. Our focus always has to be on the data. If we start trying to get too clever and focus more on how creative we can be in our visualization, we may end up with chart junk or something that looks like this example. Perhaps the worst visualization ever created. Tufte's words, not mine, although I would wholeheartedly agree with him. What's wrong with this visualization? Well, first off, it is presenting something that is not that hard to present. It's a attempting to show how, and this is, as you can tell by the colors, a 1970s era graphic. It's attempting to show how non-traditional students are an increasing proportion of university enrollment. Now, that could have been quite simply put together, presented with a simple line chart with two series, and the trends and the trajectory and the changes would be highlighted quite well, but that's not what they chose to do. What they chose to do is to include a dimension that has no data value whatsoever, this third dimension here. Use 5 colors and confusing scales. So they put years across the x-axis, used two breaks in the y-axis, used 1% gradients to exaggerate the change, and then made a confusing option to have one series come from the top and one series come from the bottom. So all these choices add absolutely no data value, no value to our end user to interpret, and make the graphic less effective. Again, why it's appropriately classified as chart junk. So, to kind of sum up, what are kind of common issues leading to poor data visualizations? First, violation of the proportional principle, that the changes in the visualization are not proportional to changes in the data. So we have insufficient or unclear labeling that lead to ambiguity. We end up focusing on how clever our design can be and not what most effectively communicates the data, and not standardizing for important but unrepresented data dimensions like inflation or population. And particularly with issues of like using three-dimensional graphics that Excel likes to highlight and other packages like to show, including more dimensions in our visualization than are actually present in the data, leading to distortions and misinterpretation. Now, to wrap that up, let's reiterate some principles of graphical excellence. So, graphical excellence is the well-designed presentation of interesting data. So it's a matter of substance, statistics, and design. So choosing good data with appropriate analysis that is faithfully represented with well-made decisions about presentation. At its best, graphical excellence consists of complex ideas communicated with clarity, precision, and efficiency. Now, I would argue, what we're really saying there is that the visualization should take something that is more difficult to understand and make it easier to understand. If the idea is not terribly complex, it may better be presented as the data itself in a table. So graphical excellence is that which gives the viewer the greatest number of ideas in the shortest time with the least ink in the smallest space. Kind of building on that second principle that we're conveying more efficiently with the least processing required by our end user and using up as little space as we can. Now that kind of comes out of a lot of Tufte's work was originally written in the 70s and 80s, where we were working with paper and not electronic space. It's almost always multivariate, so we're conveying relationships with multiple variables, and probably most importantly, we tell the truth about the data. And we're not distorting data, we're not spinning it and confusing it. So, I've used up most of my time, and what I will do is, those that want to check out are free to do so. Anybody that was interested, I'm happy to stay on for a little bit longer and walk through some of the tools available for charting and graphing in Excel. But before we jump over to that, I do want to make sure that you know about our October meeting on October 8th, same time, starting at 5:30. We'll be joined by Ashley B. Gibson, CMA, CSCA, CPA, She's a Risk and Financial Advisory Manager at Deloitte and also a member of IMA's Global Board of Directors. She'll be presenting on controllership's next normal, looking beyond the pandemic. So very excited to have a Global Board of Directors member. And in fact, I believe Ashley won the excellent Global Board member last year. So please join us for that. The link will be posted on the Bluegrass Area chapter website. And again, free for everybody to join that wishes to. And so I'll give just a moment while I change out of PowerPoint to Excel. Those that want to stay on, we will talk, and I'll be happy to take any questions that anybody has. And Sandy, did anybody post questions in the chat?
The only thing is just a couple of people asked about the slides in the presentation.
I am happy to share them. I will do it. Just if we have your email, I will get them, put your email in the chat, and I will be happy to email them out in the next day or so.
Yep, we've got a couple already.
All right. Happy to do that. Okay, so I know we're running a little bit long, but if you're interested, I'm happy to share this. So let me change this to be a little bit larger. All right, so what I wanted to do, and at first I was going to recreate the bar chart, but I wanted to highlight how some of the defaults can throw us off here. So we just insert and look through our charts, then well, first let's look at what are good charts to match the data that we are working with. So column, great for categorical quantities. Line, very effective for showing trends and relationships. Pies we've talked about ad nauseum. Composition, but it's an area chart. Bar, kind of a horizontal column chart. Area we talked about, stacked area. Now scatter plots are particularly useful for showing relationships between a couple of variables. So you can see a pattern or a trend. Now, stock chart is a specialty chart, kind of showing variation. Surface, again, using 3 variables to show changes in a plane. I have honestly never used that in my experience. I think it just, something like the small multiples would be a better use in trying to create that complex of a chart. Now, an interesting one is radar. Normally, I would be disinclined to use the radar chart, but I have seen there was a strategic finance piece a couple of years ago where Bob Kaplan was doing some interesting work and used this quite effectively. Now, where I would see it particularly effective is in something like performance evaluation, where you've got multiple categories of evaluation, and you can use like a percentile, a percentage of accomplishment, and then this becomes effective so you can see what areas you're performing worse on and what you're doing better on. And as you get better, it becomes a more perfect target. Now the tree map and sunburst, which we've already talked about. A histogram, similar to a column chart, but your x-axis, your independent variable, is usually a measured quantity that you break into bins. Now what I particularly wanted to stop here on is that this is where Excel includes what's called a Pareto chart. What a Pareto chart does is uses an organized columns ranged from greatest to smallest, and then a cumulative line chart to show where you shift from kind of the most important few categories to the trivial mini, if you will. So that's used quite effectively in things like quality control to identify the greatest quantity of defect type, and so we focus on where we're going to get the most improvement in return from our investment. Box and whiskers is used in statistics to show variation and identify outliers. And then waterfall and combo. I'll be honest, I have not used them much, although the combo is useful to combine series, although you can do that manually. Let's go back to the column chart, and I actually like having the teams on the bottom. Now, why I wanted to start here is that this default actually shows into something we're talking about in the chart junk, and that is that we're changing our axes to exaggerate the variation. So how do we fix that? Well, if we just click on our y-axis, we can right-click and go to Format Axis, and that allows us, we can change our bounds. So if we want our minimum to be 0 and we get a true, we still capture the variation, but we see that they're starting from a very big base. Now, what we can also do is we realize Excel defaults to a lot of axis lines. So we could take away some of that. That's not actually adding that much to us. So instead of maybe 200, we use 400 to have a cleaner presentation that doesn't take anything away. Now we can actually improve that by adding elements. We could add axis titles, but that's probably adding unnecessary information in this case because the teams are pretty self-evident, the y-axis. Now data labels, we probably want. Totals are an important inclusion. Include a data table or error bars. Not so much relevant for this, but would be good for maybe a line chart. A legend, but probably not necessary since our title is hits and we can make a more descriptive chart title. And a trend line would be useful in a scatter plot. Now we could also, on the x-axis, do some, maybe increase the width to better highlight that, make it a stronger foundation. Now I did want to highlight some of the tools that we probably want to stay away from. So if we click on the data series, then we have a lot of options to add visual pizzazz, which probably pull away. Something like pattern fill. Again, we're adding a lot of visual activity that doesn't tie to changes in the data. Or we could check. Or do a gradient fill. Or a texture fill. We can make this look like a wood baseball bat or something. Again, adding visual change that isn't tied to data. So probably in general, stay away from those. Just pick a solid fill. Now if you want to work with colors and get a stronger contrast, great. But not the, probably stay away from the textures. Now, just a couple of other things we could do. Maybe, and I've thrown in some data here, and we can okay, let's drop this as a scatter plot. So we insert a scatter plot, scatter, not line. Now I will highlight here, we could, if we selected all three, we could do the bubble plot. It comes, it's a little more involved, but you can see what's going on with the bubble plot is that if we select the data, for some reason defaults to not selecting the right data. So series name strikeouts, our X values, we'll map it on the home runs here. The Y values, and then the bubble size, we'll say runs. Okay. And so this works like a scatter plot, but then each bubble is the size of that third dimension. So it can be useful, but again, you're not going to get as much information about the area as you might. So let's just try to map out home runs and strikeouts, inserting a scatter plot, a basic scatter plot. Now, there's a lot you can actually do with the scatter plot. And probably one of the most useful things is actually, again, including a trend line. Now, if we go to the, and then select the trend line, go to the trend line options, here, you can, while it defaults to linear, you can do a logarithmic or a polynomial. And you can actually display both the equation, so a basic regression type equation, and the amount of variation explained in the trend line. So you're doing a chart that's essentially running a very basic regression kind of analysis. And then we can run through, and what we actually see here is that while nothing has tremendous explanatory power, at best we're explaining just shy of 10%, the polynomial is actually the best we see here. Yeah, I think just a last bit, and what I really want to get through here is just there's a lot of tools to improve your visualizations built in that we oftentimes don't access. And so let's do, I was seeing if the home run was a nominal or was a normally distributed data, so I kind of mocked up a probability plot data here. And we see it's got some twists. But what I wanted to really show you here was something we can do, actually here, if we click on, again, we format our axis, we can actually adjust. So in this case, we've got negative values on the x-axis and positive values. By default, Excel crosses the vertical axis at the 0, and we may or may not want that. That can be visually confusing. So we can actually move the axis values. So we can set it to cross at, say, negative 1.5 and actually move it to get a more traditional left and right. Now, one last thing to be useful, and I'm running through these areas, and if you have questions, I'll be happy to answer them or shoot me an email. Let's go back up here and just make a basic line chart of the and select our data. Why are you including year? Okay, now in this case we've got a chart that looks very compressed. Now, Excel does not do broken axes, but you can do a dual axis. So by selecting the data series, we can format the data series. One of the things we can do is create a secondary axis. And you can change those, manipulate those. If you get very sophisticated, you can actually cut off. I don't think I'm going to try to do that in here, but so while we can't do a broken axis, we can get a better presentation of the data series with using dual axes. Now you'll want to label which axis is which, and to not be confusing, but that is a very useful tool rather than trying to have two series that are compressing each other because they're kind of far apart, even if they're related. And these certainly seem to kind of somewhat move together. So I've run quite a bit over. I want to thank everybody for staying on, and I think we'll call that a chapter meeting. So please join us for October, and be well. And certainly, if you're interested in getting involved with what we're doing here in the Bluegrass Area IMA, shoot me or one of the other board members an email. So thank you for participating, and hope to see everybody next month.
Thank you.
Thank you. All right. Well, Sandy, I think it seemed like we had a decent number of participants.
Yes, we did.
Okay. So what do we max out at? It seemed like 13 or 14, somewhere around there?
Yeah, at the height of it, we had 13.
Okay.
We had, like, one came in and then dropped off, and just 2 minutes was on, and
okay.
then there was a few that came and stayed for about 30 minutes and then left, so.
Okay, well, but I think it sounded like we had, I was kind of glancing over there, I probably shouldn't have kept it up because it's, I don't know, I was hoping for a few more, but hopefully. Yeah,
because some of the ones that registered actually didn't show up, but we had others come, so that was good.
Okay. Well, maybe some people might have gotten confused, and maybe they thought a meeting link. Hopefully we don't have angry emails. Although I think we tried to make it clear that you just had to click on that link. But
yes. Yeah, we might do that a little different next time.
Yeah. Well, we were a little late getting some of the information out, and I'll try to do better.
And like you said, doing a reminder email, like say an hour before or something, might help too.
Yeah. But I think 13 for our first shot, and not promoting it quite as well as we should have.
Yeah.
Mm-hmm.